Okay, guys. Hello. So welcome, everyone. I'm very glad that you're all here, interested in a subject that is always alive, that is going to be alive for many, many years. My name is Jacek Milewski. I'm doing mostly backend Java development since a few years. And currently in a Circle K, where we do meaningful, very interesting software, very interesting business domain. We're doing fuel, retail, and also electric vehicles related stuff. So pretty interesting business. There I met a group of people, and this one particular person that led me to delivering the topic that I'm going to present you. And this is automated tests, and a pretty catchy title, right? Like a clickbait. But what is it about? I'm going to show you the approach that is a compilation of approaches from many sources, from conference speeches, from books, from tutorials, from experience, from personal experience. It was the most affecting factor. So we'll be discussing automated tests. This is a subject that is present on a conference since many, many years, and it's still up to date because the ecosystem is changing. So we still meet a new classes of problems that we need to test. So it's still an important topic to deliver software at a quality. It's not a challenge to deliver software, it's a challenge to deliver it at quality. There are many approaches to test your systems, and there are many approaches to do it well, in fact, because it depends on a class of a problem. We'll be doing live coding. So here is my GitHub account with a link to the source code. It is already there. It will be live coding, right? So it will be really on. We'll be making our hands dirty. So the goal of this presentation, there's just one goal, is just to show you one of the options, one of the tool that you can use when you're going to test your system, to test your business application, to test if it is delivering the business features that you expect it to deliver. So I'm just going to show you how does it all start, right? When we're learning the unit testing. I'll be focusing mostly on the unit testing. I'll be discussing what is the unit, but also as a complementary, I'll also mention the integration testing as also a requirement to test the system well. So how does it all start? We'll start with the basic. The example will be complete. It will be very simple, very small, but complete. It will present all the whole idea that I want to show you. So I had to figure out the case that we'll be discussing. So the business rule, business domain, business requirement is to calculate rating for the person. We know the person's age. Rating is an estimate how much do we trust this person. If we want to assign him a credit card or give him a loan, how much do we trust him, right? So the algorithm will be very simple. The older the person is, the more that we trust him. So we'll be simply doubling the age here. This is the algorithm, so age times 2. I have also the test prepared. This is the unit test where I construct this service that is doing this calculation, initialize it in a setup, and I have a first test that is going to test if calculate returns rating. Yeah, and this is the tool, right? This is the first step when you're approaching the unit test. You're learning a tool. This is a JUnit in this case. So in JUnit, yeah, I'm going to assert that this result is equal to what I actually expect. So in this case, if person is 23-year-old, I expected the result to be 46. So when I have the test, I can run it to see that it's red, because implementation is not yet ready, right? We're expecting 46 and have 0. Fix is very simple, is to write 46 here, right? Let's skip this for the demo purposes. Let's write the algorithm straight away. In real life, I would do something similar to writing 46, maybe not in that simple example, but just to add more test cases. Okay, so now tests are green. We're very happy. We know the tool. We know how to write assertions, how to write unit tests. We have our first unit test, in fact, running, and it's green, so yeah, we're satisfied. Very rarely we have this case that we have the class that is living on its own, without any dependencies. So we have sometimes dependencies, right? I call it an internal dependency. I'll show you in a moment why internal. So I'm gonna jump quickly to a new branch where a new class will appear. And this class is called Calc Validator. So Calc Validator is in fact validating a user's age. So if it is adult, if not, then we do not trust this person at all, so we return rating equal to 0. So in calc service, we will inject with a constructor this calc validator, and we're going to use it here. How our tests changes? Well, yeah, we have to somehow provide this calc validator. I procrastinate the decision what it will be to later, and I have two test cases, right? I'm going right now to calculate the rating for adult, which should be exactly the same like it was, and for not adult, which should return 0. So, yeah, since we are learning unit testing, we are fascinated with mocking. We discover mocking, so I'm going to inject mock here. So calc validator class and its mock. So let me run those tests now to see what is happening. And in fact, one test passes still, and one does not. So not adult is not passing because we still not have implemented this logic. But why this test is green? I wanted to have a validation in place, right? So if it is green, it means that I don't have this validation, because even if calc validator is not yet used in my service, the test is green. So I can do this one small thing. I can verify if calc validator was called with age of 23. I can do the same for the second test. So for the 3-year-old person, I'm going to run those tests once again, and now they should be both red because something was wanted but not invoked. Okay, so let me just enable this test to pass. I need to mock the behavior of this validator. So let's do it. We know the new framework, so let's use it. So for the person of age 23, it should return as true, as a valid person. So we can calculate rating for this person. Okay, and for the 3-year-old person, it should return false. And with this test setup, I can run my tests to confirm that they are still red and implement the logic here. The implementation will be very simple. I'm going to add this if statement and pass the age as a parameter. And that's it, in fact. Else I'm going to return rating equal to 0. Now the test should be green. Yeah, so we have it. Right? We have a new tool. We know what are mocks, and we know how to use them, and we know how to write tests with mocking. And now I'm going to stop because we're moving towards the clue of this presentation. There are some issues in this code. I want to display them first and later show them in a code. Just two issues. The first one is that test duplicates the implementation. So my test knows a lot about the implementation. And second case is that we might have problems with refactoring this code. This production code, also the test code. While the test tests should help us refactoring without destroying things, without breaking things. In this case, refactoring is difficult. Okay, so duplicating the knowledge in tests and tough refactoring. Why and how? Okay, so let's get back to our tests. First, let's start with pretty soft problem. So we have this calc validator, which has a method age is valid. If I'm going to rename it, because I feel that it should be renamed in the future, the changes will be reflected in many places. Let's say not age, but person is valid. Right now I have also, this renaming will be also reflected here in a service, which is natural because I'm using it here. So it's very natural. But also, it will be reflected in test, which is not that natural, right? So I have more files where this rename will be visible, which is a very good way to hide this dirty hack in a pull request, right? If you have changes in 50 files, then probably your reviewer won't notice the dirty hack that you did in this small place. But this is not very good if you have a pull request where simple rename is taking a lot of attention during the review. So this is the first issue. I'm going to revert this to name it age is valid. The second level of problems is that in this case, input params for validators are exactly the same as input params for the accessor method. So what will happen if there will be something more, and this X will be calculated here by some strange algorithm. So yeah, here this is simple, this is obvious, but what should I do in my tests? What should I inject here? Should it be any int? Or should it be maybe some magic number, exactly the same? But we don't like magic numbers, right? So maybe it should be something named, so it's not that magic, right? So we're clear, but nevertheless, does it have any meaning for your tests? If you give here 1, 2, 3, 4, what does it mean if you gave it 1, 2, 3, 4? So does it influence the test's result somehow? So is this really that important that I have to write it here? So for me, when I'll be reading this test after 1 month, then probably I will have to stop and think what this variable means and what was the intention 1 month ago. Okay, so this was a bit harder, and the hardest thing is what if my validations rule will change? What if right now valid age is 28 years? So this is where the duplication of knowledge strikes you the hardest. So in our tests, I'm pretending then that for 23-year-old person, I should return true, while my production logic has changed, right? So right now, this is we are seeing right now the benefits of mocking, but we're also seeing the threats of mocking, right? So we have a different case in a test code than on production, and it's very tough to spot during the tests because, well, I have changed the implementation in Validator, so let's say that on pull request nobody will notice that also in some unrelated test this change should also be done, right, to 29, for example. So my tests begin to lie. And we tend to agree that the unit test might lie because those are unit tests, right? Those are not, we have different, another levels of testing, but do they have to lie this much, or they can maybe lie a bit less? So let's change it to 18 years again. And let's see whether we can do something with those issues. Yes, we can. So the first thing that I'm going to recommend is to decide what is my unit. Does it have to be a class? Why do I use mock on this level? Why do I, well, in fact, I agree with myself that this will be a point where something may lie, right? Somebody could change the implementation in production code, but forgot to change the tests. So tests behave differently than a production implementation. So why do we use mocks here? Maybe we should switch to using real implementations, right? So my unit is not a calc service, it's not a service, it's not a single class, it's not a single file. Files are so artificial, right? Our language and our, let's say, the possibilities of our mind force us to split big parts into smaller parts, into files, right? But this is not how business works. So the feature is delivered by a group of files, not by a single file. So my unit is not a file. It's not a service file, it's not a validator file. My unit is a set of files. So if I change the implementation from mock into calc validator, into new, real implementation, then I can remove all those mockings. And I can remove this verify. Yeah. So all of you that felt this pain when I was adding verify, now it's better. And also I'm going to remove the mocking here because this is not a mock now. I'm going to run the test and they should be green. Yeah, so I'm testing the business behavior right now. I'm not testing the service class, I'm testing the business behavior, which is consisted of a group of classes, not a single class. Okay, so I'm moving towards the some kind of group of files, as I named it. I'm going to name it a module. A module is a group of classes to serve a business needs. A module has an API. A module exposes its behavior through an API. So let's see how this API might look like. Right now, my API is de facto the service, right? It has one method, which is not private. It's package private, but probably it's going to be public. So just the one method. So let me simply switch branch for a moment. Not that much has changed, except that new annotation has appeared, which is right now just a marking annotation. It's doing nothing. It will be doing some more things later, but my calc service is going to be my API, so let's explicitly call it an API. Right? I want to be able to know whether this is some service or API just by looking at a file name. Okay, to be even more explicit, I am going to annotate it with module API. So now it looks better, but still my API, I want it to be the facet to internal implementations. So the facet and API shouldn't be that much complicated. You know that in real life, in services, we have a lot of logic, a lot of code, a lot of private members, right? So I don't want to have it in my API. So I'm going to keep my API classes as just as a facet. So I'm going to delegate all the calls to services. So I'm creating a class right now, calc service, where I'm going to delegate all the calls that are called to the API. And as you see, I have one line here. Right now, my API is doing nothing except of delegating. This is IntelliJ refactoring issue, so I'm going to, of course, not construct the service here. It will be injected. And let's take a look at our calc service. The calc service has a private member calc validator, and yeah, it will have also all-args constructor. So to be able to inject the calc validator, and it doesn't have to be public. Right? It still will be in the same package. And yeah, so the service looks like that. We know it, right? We've seen this. So this is my API. So the unit, my unit right now is not going to be the class, it's going to be the API. My API will be my unit. So a group of classes, a set of files that are going to serve and deliver the business functionality and that expose an API. So my unit is a module that exposes an API. So of course, we need to group somehow those classes, right? It can be grouped in many ways. It can be a bounded context, an aggregate. It can be a package. It can be a module from Java 9. So you name it. You know your system the best, but you have to group it somehow. And grouping it in a, let's say, technically oriented packages is not a good way, right? So right now here you have the services, the DAOs, the entities, the APIs. It's not a good way. We're grouping it in a module which is named, in a package module, however you call it, which is named calc, and its role is to deliver the calculations. Right? We have API services and validators inside. Okay, so my API right now is a single entry point for my module, and this is what I test. It exposes an API, public API, and this is what I test. API internally can call the service, or many services. If it's more complex, services can call other classes, but it doesn't matter for my unit test. The one thing that matters is that it exposes an API. Does it work on production? Yes. So it's not only working on demo. This is a snippet from my production code where we have a module named TC from terms and conditions, where we are versioning terms and conditions, checking what user has accepted, what not. And as you see, we have 4 services here. So this is pretty big API, and we are simply delegating all the calls to our services. And module unit tests, if we have this module, again, I'm moving away from this constraint that files are something meaningful. So files are not meaningful. So how I test this API, I have one test file per one API method. So not for the whole API class, just one test file per one API behavior or method. So for this API, I have around 10 files, which are, of course, named using some conventions. So the name of the API, the name of the behavior that is tested, and the suffix. Inside the files, I'm testing all the edge cases. So I also name the behavior and test all the edge cases that might happen in this API. I'm not starting the application context. It's still not using any framework, so it's running fast. So it's still unit test, right? It's fast. But you might have noticed already that it's not always that simple. We can't test our whole system as a single module, right? We might have multiple modules. And in this case, I'm going to present you how should the interaction between modules could look like in my case. So a new module has appeared. Again, I'm changing the branch, but in fact, not very much has changed. Apart that, yet another validation or verification has appeared. We have a user API, which is, as you know, if I call something an API, then this is a module API. So this is something that I trust that somebody has already tested as a module, unit test. So I'm going to use it, and it has yet another verification of user based on its age. So what do I do in a test in this case? Well, in this case, I'm using mocking. So this is where my module has its boundaries, where my unit test has its boundaries. So as I said you before, we can trust our tests up to the level where mocks appear. So this is where is the limit of my trust. So I trust that I have my calc API tested. But here is the mocks, right? So here is the moving part. So this is where I agree that these errors might occur. But I have my whole module tested. Okay, and here, of course, the mocking appears, right? So I mock that user API verify user will return false, and I test the behavior of my module here. So that's it when it comes to the external modules. But we have yet another external dependency, let's say, which is a database. And database is a bit different than external modules, because let's say that external modules are totally basic, right? We write them, they depend, the implementation depends on our business rules, business needs, but the database in most cases is pretty similar, right? So mocking it might be a bit more cumbersome. So let's switch to the branch where the repository appears. And yeah, the business requirement right now is to save each calculation in a database, save it in a repository. So I have extracted the perform calculation method as a private member. It's doing nothing more than previously. And now I have a room to add this persistence, right, to save this calculation in a database. So let's see what should I do in my tests. Okay, so my repository is right now nothing. So I just want to keep it nothing for a few more seconds. It's injected into calc service, right? So as it requires repository, I'm injecting it here. And we have a new test case that calculate behavior does persist rating, in fact. Okay, so what is my calc repository? My calc repository will be in a production code. It is a CRUD repository, simple. CRUD repository is if you're familiar with Spring, has just a basic implementations of CRUD methods, right? So delete, find, save, and some utils also. I don't need anything more right now in this case. So in my test, I'm going to use new calc test repository. And what is the calc test repository? It is implementing the same interface, the calc repository, the same as in production, and it's extending the in-memory repository, which is the CRUD repository again, right? So it has, we've been here a few seconds ago, right? It has all those CRUD methods. So how does it implement this interface? Well, hash map, yeah. So my database will be in memory. I will keep all the entities in a hash map. So I'm implementing those methods, right? The implementation is very simple, right? I'm saving, so putting the entity in the database, I'm finding, so returning all values, and the methods that I'm not using, I'm going to throw an exception. I'm not going to pretend that I implemented it if I'm not using it. So somebody that will need it probably will see this exception and have to implement it. Yeah, so the repository is in fact, has the same interface as my production repository, but stores the data in a memory. So I don't have to, in my unit test, I don't have to issue a connections to a database. I don't have to connect to any database. I don't have to have anything. I want it to be fast. Okay, so how I'm going to assert it? So how I'm going to assert that rating was persisted. I'm going to call my calc repository, and I'm going to do it as simple as I can. So I'm just going to check if it has one calculation persisted. So of course in real life I would do some more strict validation, but right now let's stick that something was saved. Okay, and the test is red because expected size was 1 and the size actual is 0. So let's go to our service, and yes, it has to be red, right? Because there is no implementation yet. So let's implement it. So let's save a new entity. This is a simple calc entity that has properties of age, which I'm going to take from the param, and the result of calculation, which I'm going to take from the result. And I'm going to run those tests once again to see that they are green. So something was truly saved in my database. Why I don't use mocks? Because a CRUD repository is in most of the cases the same, right? So I don't have to write mocking for every test case in every test, while it's still the same. So I have a common class in-memory repository that I'm extending. If I have more repositories, then I simply add more test repositories into my tests, right? So yeah, that's it. This is how I cope with the repositories. So we know where are the moving parts, right? So mock of external module is the first moving part, and the second moving part is the repository where I fake it. So it works, provided that I wrote it well, right? But I don't have, I can't be sure. So this is where integration tests come in place. They're about to confirm that everything works well together. So let's see what my integration tests are doing. Now we have a framework dependency. Yes, so we're starting Spring Boot application here. And we have few annotations that has appeared, right? We have controller, which is a REST controller. It's exposing a post under this address, under this URL, and it's returning a JSON with key result. Right now, the result is 0 always, and it returns an entity. The repository became a repository right now. The entity is an entity. I'm going to use H2 database for the demo purposes. And the service is, the API is still module API, but the module API annotation is right now a component. Right? So it's simply yet another name for a component, but more meaningful. Okay, and the integration test is here. So it starts the whole application on a port 9090. The rest assured will be used, and I have an auto-wired calc repository here. So this is a real repository. This is auto-wired one. This is not faked. And I have my first integration test. So let's see what my integration test is going to test. First of all, I'm going to confirm that my REST API is in fact exposed properly. Right? So I'm going to check if I received the status code. Second thing, I'm going to assert if this response has a valid body, if it in fact returns me the result that I was expecting. So I'm going to get integer from key of result and assert that is equal to, here I'm passing 24, so it should be 48, so double the age of the person. And yet another moving part is to assert that calc repository has this calculation saved. So I'm going to find all the entities and assert that it has size of 1. I'm going to run this test. This will be a bit slower because it is integration test. It's testing a bit more. So it's starting my framework. So very good. This is what I wanted to test. It's red because, well, I'm returning 0 from my controller, right? Let's jump to the controller and use my API class here. So calc API, calculate rating with a param of age, and let's run those tests once again. Yeah, so those 3 lines are doing, in fact, what my integration tests are meant to do. Yeah? Confirm that API is exposed, that it's returning the result, and that the database integration is working. Let's get back to our slides to see some drawings, right? To see something with the rectangles. Yeah, the calc API is the thing, and the module API, the calc module is the thing that I test as a unit, as a module, and all the things apart from that, so database, controller, and HTTP, if it works together, I'm testing it with integration test. So here I'm confirming in the integration test that my REST API is exposed, that my API is secured, if there's any security, and all the faked and mocked dependencies are working as I expect. Also, if there are any exceptions, I'm checking if they are properly handled, right? So if I'm not returning for 500, that I'm returning some meaningful status code and the error messages. And all of this is also documenting my contract, my API contract, right? This is still not the best way to test the contract, but I mean that there are consumer-driven contracts, there are other tools you can use, but still it is good enough to test that API contract and document it. Okay, so to draw it in yet another way, we have the scope of unit tests displayed here as an API, a thing that tests an API, the services and the repositories, the faked repositories. So the logic that lies in services is tested by a module tests. So if you have logic in services, if you really have complex logic in a services, this is the one of the approaches that you could use. If you have a CRUD application, probably you'll find out that these module tests are very simple because well, there's no logic, right? So there's nothing to test as a module test. So probably you should focus more on an integration test where you simply test your API and the behavior of your service, of your system. And you also confirm that controllers, so the REST API is exposed and the real database is in use and is working as you expect it to work. So how do you test your code? Right? A very simple question that has very many answers. How many integration tests do you have? How many unit tests do you have? How many micro tests you have? It depends on the class of a system that you're building. Most of us probably are building the business serving applications. So I think that we are pretty in a similar situation, right? I've also mentioning here a micro tests, which is, for example, if you have a CRUD application, which is simply getting data and returning data, probably you have only parsers and validators, right? Maybe parsers and validators are the cases where the unit can be a single class, this parser class, right? So there's not that much interaction between, so the parser and validator are independent and they can be tested, unit tested, where unit is a class, so yeah, I call it a micro tests. And you can have also node tests, which probably can be the hardest to explain why you don't test your code. Okay, so this was the strategy, right? This was the approach to testing. So it's not that simple to, let's say, implement. So you cannot start tomorrow and have your tests written like that. But you can simply start to pick one class, pick one service, decide on one business domain, and simply move it to a separate package and try to test it as a module, as a group of classes, not as a single class. And another part is, I want to emphasize the things that I was using during this presentation, but right now I'm going to tell a bit more about it. So the first thing is the convention that I use is the naming convention, right? So we are used to use the given when done in body. If you're using Spock for Java testing, you're in fact enforced to do it. If you're using JUnit, I think that using comments in body is a convention. But what about the test name? So there's a lot of conventions, right? Even in the same file, you very often meet a very different approaches how to name this class. So for future me that will be reading this test after 1 month, it would be good to have some conventions. So if we have given when then in body, we have when then given in a test name. So first, I describe the behavior that I'm going to test. So calculate is my behavior, right? Then I write what I expect. So then it should return rating. So a happy path, right? It should return valid rating. Given if there are any meaningful conditions, then I give it at the end, right? So this is the convention. Very nice to use. Okay, the second thing are the builders. So very often in tests we need a value object, some entities, something that has several fields and has also several parameters in a constructors, but not all of those parameters has meaning in tests, right? Sometimes you simply don't care about two of 3 parameters. You care about only the age, like here. You don't care about the others. So in tests I use the builders, and I assigned default values to it. So when I'm reading the test, I know that only age matters, right? So there is some specific behavior that I'm going to test for the person that is 24 years old. And I'm building this entity. What's more, if I have builders, instead of building, I can say that I want to save it in DB, in database, right? What InDB is doing, it's in fact building an entity first and later saving it in a repository. In what kind of repository? Is it a real repository or fake repository in memory 1? It depends what I am going to inject here when I'm constructing a builder. Right? So I have the same approach in a unit test as in an integration test. So I'm using the same API. So looking at this test, you can say what repository I'm using here, if it's a real one or in-memory one. So you don't have to switch contexts when you're switching from unit to integration test. Not having to switch context, it also means that you can simply copy unit test and make it an integration test because a different repository is injected there, right? So this is what I do very often, because in unit tests, I'm testing all the edge cases, and for integration test, I pick 2 or 3 most important ones and confirm that in integration, the system also works. And the TDD. As you've seen many times during this live coding, I've had red tests, right? Because I don't trust tests that I haven't seen red, and I made them green afterwards. If test wasn't red, if it was always green, I don't have a proof that it, in fact, is testing something. Like here, maybe you've already noticed what is wrong here, that there is no assertion in this line, right? This is a test with an assertion, and it's impossible to spot. So you have to see this test red to know that it is testing. It's a very good way to improve your coverage, writing a test without an assertions, but well, makes no sense, right? So in the first case, I was calling the isEmpty method on array list, and in a second line, I'm calling isEmpty on assert j. So I'm doing an assertion, in fact. Okay, and the last thing that I want to share with you is this misconception about the speed of development and testing. Very often we say that something will take us more time to implement because we have to add tests to test it, right? So then, of course, there are ideas. So please do not write test for this feature, so it will be faster. So there is this misconception that testing slows down the development, which is totally opposite. Here we can see the speed that drops. It's my imaginated chart, of course. So this is how I see it. If you're starting without writing test, so let's say that red team is starting a new project and is building the new features very fast at the beginning, right? But later something happens. They can't build up the next features because they promised to the business that they are going to speed up a little bit by skipping the tests. Yep. So they were really fast at the beginning, but later they can't add new features at the same pace because they are breaking stuff that was previously implemented. So here is the green team coming, right? The green team that started already. They started the project with good tests from the beginning. Yeah, and they were slower at the beginning because they had to do this setup, right? This test setup, the unit test, the integration test, the Jenkins, the CI, CD, the notifications, and all of this. But still, when the next features, they can freely develop new features and they can safely add new features without breaking old features that are already in place, right? And they meet somewhere here. And red team probably is searching right now what they did wrong, and the green team just goes by. Okay, so that's it. That's everything that I wanted to present to you. Thank you very much. I would like to hear your thoughts, hear your questions. If you have any questions, you can ask them right now. And please rate my talk in the application. Okay, do you have any questions? Okay, so I'm here still. You can approach me. Thank you very much and have a nice day. Enjoy the conference.